Alright, so for number 10, they talk about, let's see, some money invested at 5.5% compounded continuously. How much will there be in 10 years, and when will it double? So anytime you see compounding continuously, you're going to use this formula, okay? And that's just a formula you have to know. We've talked about it in class several times. So for the PERT equation, or formula, for compounding continuously, P stands for the principal. So this is how much you start with. E is that number, 2.718, that goes on. R is the rate, and T is the time. So for this problem, they want to know in 10 years, if you start with, if Casey started with $4,000, the rate is, again, you have to change it to a decimal, just like we did on the problems at the beginning. So 5.5 is 0.055 for 10 years. So you simplify that to 4,000. E, 10 times 0.055 is this. Input it into your calculator. And again, if you do it properly, if you do it right, you will get 6,933 and 1 cent. Okay, so that's what you have in 10 years. The second part of the question is, when will it double? In other words, when will Casey have $8,000? So we want V of t, or V of t to equal 8,000. So we want this side to equal 8,000. He started with 4,000. The rate is the same. And we're calculating for time. So we want to isolate this part of the equation. So that means that we have to divide by 4,000. Okay, so then that leaves you 8,000 divided by 4,000, that's 2 e to the 0.055. Okay, now that's as much as we can do right now. Unless, you can do guess and check, and just plug in different values for t. Since 10 years gave you 6,900 and you want to get to 8,000, you could start from 10 and move up, right? But that's a valid method, but it's not very effective. So we're going to use what we learned about logs to solve this equation. So since my variable is in the exponent, the only thing I can do right now is convert this equation to a log equation. Okay, so I'm going from exponential to log. So the base is z, so I'm going to put natural log of 2, because that's the value I want to reach, that 2, and it equals the exponent. So in order to solve for t, I divide both sides by 0.055. Okay, so whatever this gives me on the calculator, that's my answer. So it turns out to be, let's see, I did it earlier, 12.6. And the unit is years. For number 11, let's do it here on the side. For number 11, you have the principal amount of $5,800 earning 7.5% interest compounded semi-annually. Okay, so this is not continuously, okay? So you cannot use the formula that we did for number 10. So for this one, we're going to use V of t equals the principal 1 plus r over n. So this, we're using the same formula that we used in the beginning problems, right? And these are n's, not so right here, this one and this one are n's. I know they kind of look like h's. So the principal is 5,800, 7.5%. Semi-annually, that's twice a year. So that means n is 2. So I want to know in 10 years. Okay, so I started with 5,000 5800. 1 plus, and the rate is 7.5%. So remember, you change it to a decimal twice a year. That n, you write that same value up on the exponent, and it's for 10 years, right? Okay, so then this is 5800. 0.075 divided by 2, you have to either do that by hand or or just do it on the calculator, so that you get 1.0375 to the 20. You input that, and you get, let's see, 12,111 with 28 cents. Okay, so that's the answer for 10 years. The next question is, when will it be worth $15,000? When will it be worth $15,000? So I'm going to put, in place of the V of t, I'm going to put 15, oops, sorry about that. I'm going to put 15,000, and it equals 5,080, 800. And it's the same interest rate, and it's semi-annually, so it's going to be 1.0375. That's going to be the same, and so it's going to be 2t. And so the n has to be, taken into account in the formula. So that's why the exponent is 2t. So first thing I'm going to do, since I want to isolate the base and its exponent, the first thing I'm going to do is divide both sides by 5800. Do that to both sides. So when you do that, 15,000 divided by 5800, you get 2.586 and ... So keep whatever numbers on your calculator. 2.586 ... equals 1.0375 to the 2t. So again, we have the same situation that we had in example number 10, where I have a base, like I have an exponential, and I don't have the answer just by, I can't think of the answer off the top of my head. So I need to use logs. I can convert this exponential into logs. So anytime you get in a bind where you need to solve for the exponent, and you've got the base isolated with the exponent on one side, just switch it over to log. So this is going to be log base 1.0375 of 2.586. Notice I keep putting ... equals 2t. So then you're going to divide by 2. Okay? So keep that 2.586 number on your calculator screen. Do not clear it. Okay, just keep it on your calculator screen. Because now, let me move this up a little bit. When you, now we're ready to use the calculator. This is how you're going to set it up. Change of base theorem, because our calculators do not have this base, right? They only have base 10 and base e. And here I have 1.0375. So I'm going to have to use the change of base theorem. Okay, ... over log 1.0375 divided by 2. So you have this number here on your calculator, right? So all you do is you put, you put log of the answer, because that's what's on your screen, divided by the log of 1.0375 divided by 2, and then equals. So when you do that, you get 12.9. So in 12.9 years, you will have the $1,500.